Hello, everybody, and welcome out to podcast number 346. We're talking about the Takt production system. This is part 10, and we are going to head in a good direction. We're talking about the concept today. Stay with us.
This is the Elevate Construction Podcast, delivering remarkable content for workers, leaders, and companies in construction wanting to take their next step. Get ready to step out of your comfort zone with Jason Schroeder as he encourages you to do better, live a remarkable life, and expect more. Let's go.
Welcome, everybody. I hope you're doing well. We're going to continue here. We're done with the fable. We're done with the introduction. We're right into the meat of the book. When I look through here, I think that we're about a third of the way through. You're going to love the rest of the content, so stay with us. On we go. The concept, tact planning. What is tact? Tact planning is a detailed one-page, one-process flow schedule that focuses on throughput, bottlenecks, and ultimately creating flow. It is accompanied by lean practices to be the most effective scheduling tool in the industry for construction because it creates stable construction environments, enables total participation, and provides a basis upon which to improve all aspects of construction. In German, the word Takt means beat frequency or the regularity with which something gets done. When used with lean, it means standardization, predictability, and the heartbeat of the project's production system. To be a tact plan by definition, it must be a visual schedule that clearly shows time and space, and how they relate to workflow, trade flow, and the logistical flow of the project. Tact creates geographical, rhythmic flow from area to area, making it a location-based management system. It also has to be planned with the right buffer management and one that stabilizes the pace of work with what is called one process flow that limits work in process. And lastly, it has to have a reasonable overall project duration. These are the basics to meet the definition. Tact also means cycle time. It symbolizes the need for a responsible rhythm of work in certain production areas, otherwise known as tact zones, as opposed to the left justifying of activities to their early start dates in CPM's famous forward and backward paths. To a builder, tact communicates the need for flow. Here are commonly found definitions and usages for flow. Number 1, verb. Of a fluid, gas, or electricity, move along or out steadily and continuously in a current or stream. From here the river flows north. 2. Go from one place to another in a steady stream, typically in large numbers. The firm is hoping the orders will keep flowing in. 2. Noun. A. The action or fact of moving along in a steady, continuous stream. The flow of water into the pond. B. Steady, continuous stream of something. She eased the car into the flow of traffic. When water flows, it runs in a relatively consistent and continuous stream down an unobstructed path. When water does not flow, it's usually due to the twists and turns, obstacles, changes in elevation, or other hindrances. Additionally, water flows when it runs together in a coordinated pattern with adequate space. To explain what we mean, consider 2-gallon jugs of water. In this example, the first jug is tipped over and pointed straight down, allowing the water to pour out without squeezing the jug. As the water pours out, there is a gurgling sound caused by the friction of the air and water fighting for space as the jug empties in a time span of 11 seconds. In contrast, the second jug is turned over and the bottle is spun in a circle, which creates a spiral in the water or flow vortex. As the water spins, the center of the vortex allows for the air to flow into the bottle at the same time as water flowing out. It only takes 5 seconds to empty the second jug with the use of the flow vortex. The best flow of water is developed by coordinating the water in the most optimized manner and by creating space in the center of the vortex for air to rise. Forcing the water through the opening as fast as possible is not effective and causes splattering and turbulence. This is what happens in CPM by pushing construction activities through the network of resources as fast and or as soon as possible, early start. The critical path will erupt with roadblocks, air bubbles, that interrupt the flow and increase the overall duration of the project. Takt, on the other hand, with its coordinated approach and space given for the occurrence of roadblocks or air, is similar to the flow vortex. When all parts are working together to achieve flow, the water can move in a steady stream while simultaneously allowing air to rise up to the center of the flow vortex. This will beat the other system every time because it gives space and time for roadblocks to rise and be removed from the flow of work. We've discussed this at length because we want this visual to stay with you throughout this book and as you begin your journey to bring flow to your job site. The ultimate question for any successful schedule system is, at least in part, does the system enable a visual and coordinated flow? And does the system bring problems to the surface quickly so they do not interrupt the flow? The answer to these will guide us as we take this journey. Flow is a priority for construction. Why? Because flow enables the very long supply chains upon which we rely in construction by holding to consistent dates, and it reduces the material inventory levels and worker counts on a project site at the end of that supply chain by allowing us to bring out materials just in time. This is important because the reduction of material inventory is essentially the reduction of overproduction in construction, which then reduces all other wastes. When overproduction and excess material inventory are reduced, the need for fixing defects, overprocessing, waiting, transportation, and motion are reduced because we are using the genius and capabilities of the team, maintaining a consistent schedule and flow, one process or one tacted process at a time. The effect that waste, variation, and roadblocks have on the production in the field are widely recognized and accepted, and at a minimum, they culminate in wait times and prevent good flow. If we maintain flow, prepare our work, stabilize our supply chains, and hold our dates according to a good takt time, we will have a good flow of information, worker counts, and materials because the dates, rhythm, targets, and expectations all remain consistent, steady, and continuous, just like when water flows. Scrum and the last planner system also advocate and support flow, but are not able to maintain it fully when based on a CPM system of milestones because they are not receiving materials on time within the chaotic and non-visible CPM system. Takt is the best companion to these systems because it can properly identify key milestones within a flowable system. Takt levels the workload to the point that agile systems like Scrum and Last Planner have a fighting chance in the short interval. You can take the best basketball players in the world and encourage them to make slam dunks after placing the hoops 25 feet in the air, but they will fail in their endeavors. That does not reduce the effectiveness of the players. It means the game itself was impossible. When CPM puts Scrum and Last Planner into a game with unrealistic end dates, non-contextual and rhythmic milestones, and non-transparent plan visualization, we are setting our hoops 25 feet in the air. Takt brings us a game where we can win, with rules we can follow, and the autonomy to meet the short interval schedule targets. It brings the hoops back down to 10 feet so the players can again dominate on the court. Definitions. Before we continue, it feels appropriate to define some terminology as we move forward in our Takt journey. In the first edition of our book, some definitions were different. We have standardized our definitions to align with takting and what is generally accepted in Europe and the United States as Takt terminology. Taktzeits, German for baton, beat, or rhythm. Takt in takt planning. The individual cell representing the intersection of time and space. This can be empty or include a takt wagon. It is the basic unit of a takt plan. Takt plan. The strategic and logistical visual plan that shows the takt trains in relationship to each other per the specified takt time with columns of time and rows of takt zones or geographical locations or general sequences. Takt control. A tactical system of holding the dates, stabilizing procurement, limiting work in process, and finishing as you go. It is the process of using the execution plan within the takt plan that is constantly evolving and making short-cycled adjustments of the takt plan to increase flow and improve the execution of the work. Typically, Takt planning takes 20% of the time in development, and the remaining 80% is spent in Takt control. Takt phase. The grouping of Takt trains by zones that compile to make up similar types of scope. Example, structural, rough-in, and exteriors. Takt time and throughput time are specific to Takt phases. Interdependence tie. A line representing key transfers between Takt phases that are represented in a Takt plan. Takt zone. A production area that is determined by its repeatability and ability to fit into a rhythm with other areas to balance the overall production schedule. This is a batch of geographical area that is either increased or decreased to achieve flow. Takt train. A series of wagons in a Takt zone. This is also sometimes called a Takt sequence. Takt wagons. One or more work packages or scopes of work packaged into a single cell in a Takt train, usually shown on Excel, or a Takt when in an application like Takting. Work packages. Features of work or scopes within a Takt wagon. If found within the same Takt wagon, they should not constrain or hinder each other in any way. Work steps. The tasks in the installation process within the work package. For example, if your work package was overhead electrical, then the steps might be conduit runs, light boxes, fire alarm, cable tray, low voltage, etc. Takt time. The measurable beat time, rate time, or heartbeat. In Lean, takt time is the rate at which a finished product needs to be completed in order to meet customer demand. It is the syncopation or rate of beats, such as one might find on a metronome. To expound, takt time is the duration of the time scale into which the Takt wagons are fit. If the takt time is 5 days, the wagons fit into multiples of that duration. So if a wagon includes the work package of overhead mechanical, and that overall duration is 15 days, and the takt time is 5 days, there will be 3 Takt wagons that say overhead mechanical and 3 timescales. Stagger. The difference in the start dates or end dates for Takt trains that educated the throughput calculation with time. Flow. When something moves together along a steady, continuous stream with a lack of resistance or turbulence. There are 3 types of flow: workflow, trade flow, and logistical flow. Typically, a Takt plan will only be successful if we achieve over 80% trade flow, over 60% workflow, and over 20% logistical flow. More will be discussed about this later, but trade flow is typically prioritized because the process in construction is replaced by the piece in manufacturing, so the process is the flow unit and provides the maximum amount of flow efficiency. In Takt planning, there are 3 main considerations. Number 1, continuity. The flow of work within a Takt train or sequence without interruption or efficiency gaps. Number 2, rhythm. The repetition of work, specifically Takt trains, in a repeatable time interval. Flow here would mean each process works through Takt zones at the same rate or rhythm. 3, consistency. Consistency means that materials and worker counts are leveled and consistent, allowing for standard work, just-in-time deliveries, and stable crew compositions. Waste. Any non-value added unnecessary work steps or conditions that hinder normal operations from delivering value to the customers on the project. They usually are classified within the following categories: overproduction, excess material inventory, transportation, motion, defects, overprocessing, waiting, and underutilizing the talent of the team. Variation. A change or difference in the condition, amount, or level of anything in construction that interrupts the flow of work as planned. Resource efficiency. According to the book This is Lean, Resolving the Efficiency Paradox by Nicholas Modig and Par Ahlstrom, resource efficiency focuses on efficiency using the resources that add value within an organization. Flow efficiency. According to the book This is Lean, flow efficiency focuses on the unit that is processed in the organization. In construction, again, flow efficiency prioritizes trade flow because the process is the flow unit. Throughput. The rate at which material or items pass through a system or process. When you take raw materials and process them into finished goods and deliver it to the customer, the measured rate of that activity is your throughput. Overall duration. The start date and end date of the construction of the project, which can be determined by Takt planning or stipulated beforehand, to which the Takt time and Takt plan needs to be adjusted to meet. Roadblocks. Anything that has the potential to impact work and construction that can be identified ahead of time and can be removed before the work begins. These are temporary roadblocks, and the removal of them should be the main focus of the team. Examples of roadblocks are missing information, a defective part or material, coordination issues, procurement issues, and errors in pre-planning. Constraints. A condition on or around the project that limits or restricts something or someone in the course of the project. These are typically permanent and cannot be removed. Examples of this might be adjacent geographical features, weather, lack of space, municipal restrictions, or anything else that permanently defines the parameters of the project. A project must be successfully planned and carried out within these constraints. We use the term constraints much differently than the lean community at large. It would be our preference that we adjust back to the proper use of the word constraint as something that must be dealt with and begin to use roadblock to define removable blocks to flow or production. Bottlenecks. A bottleneck is any resource whose capacity is equal to or less than the demand placed upon it by the entire system. Material inventory buffers. The stock of material that a company maintains as a protection against unforeseen circumstances that is neither excessive nor too small to stop work due to lack of materials. A material inventory buffer is considered right-sizing the stock of materials to enable work, but does not create unneeded inventory that needs to be moved, replaced, repaired, or processed. As materials are harder to come by or become more unpredictable, the material inventory buffer may need to increase. Capacity buffers. Tasks, materials, or people that can be used to fulfill inventory or time buffers after a delay, stoppage, or unexpected demand. Extra capacity for the sake of responding to variation in productivity and rework. Time buffers. Extra time worked into a process in anticipation of unforeseen conditions and/or historical delays of up or downstream processes. This extra time allows teams to synchronize the Takt trains. Just-in-time deliveries. A strategy in supply chain management intended to synchronize orders from suppliers by production areas and standard delivery schedules to the project site in the right amounts at the right time to supply material inventory buffers. Standard space units. The smallest repetitive part in a project within a work package. Line of balance. Line balancing is a production planning and tracking strategy that involves balancing the trade partner and worker production time, then matching that rate to the Tack time. Tack time is the rate at which parts or products must be produced in order to meet customer demand. Okay, everybody, we have gone through the introduction here of the concept and the definitions, and now we're going to go into a very nice section where we cover lean concepts, where we learn what did Brad learn as he began creating the Tack plan. You'll see that in the next section. On we go.
Please join us next time in elevating the entire construction experience for workers, leaders, and companies coast to coast. If you're enjoying the show, please feel free to share with your construction colleagues and help us spread the word by rating, subscribing,